Hello and welcome to this lesson where we intend to illustrate the application of matrices in solution of simultaneous equations, this time around using examples. Again, please notice that this lesson is a continuation of the previous, so you need to check the previous before you come to this one. And as always, please like, share, subscribe, I'd appreciate it. Let's turn now to the two examples. So the first example we have before us a set of simultaneous equations. 4p plus q is 6 and 2p minus q is -3. We're supposed to solve this set of simultaneous equations by using matrices. And so the first thing we need to do is form three matrices. The 4, 1, 2, minus 1, which are the coefficients of 4p, q, 2p minus q. That is the first matrix. The second matrix, which is the matrix of the unknowns that we have before us, which is P and Q. And 6 minus 3, which is the last matrix, is a matrix of the answers for the sets of simultaneous equations that we have. Again, the next step is we look for the determinant, which is 4 times minus 1 minus 2 times 1, and the answer gives us -6. From there, we look for the inverse, which is the reciprocal of the determinant times the transposed matrix. We're having 4 minus 1. These ones we interchange so that you have -1, 4. And the signs for 1 and 2 are also reversed so that you have -1 and -2 respectively. Simplifying this gives us the inverse, which is a sixth, a third, and -2/3. With that, now we multiply the matrices that we had at this particular stage with the inverse we just obtained. So that I have this particular matrix multiplying before the matrix of coefficients, and again before the matrix of answers, like we have here. Again, we say that anything, so we say any operation before the equal sign we simply reduce to the unknown. So we just need to have PQ remaining before the equal sign. The reason is the inverse of a matrix times the matrix gives us an identity matrix. An identity matrix times the matrix gives us the matrix. The only work we have before us here is to simplify whatever there is after the equal sign. So multiplying the inverse that you've just obtained with the matrix of the answers that we had, 6 minus 3. And therefore that gives us PQ is equals to this one here. And we simplify that. Please follow the rules of multiplication of matrices and you get the matrix half 4. That tells us that P is simply half and Q is 4. We now turn to another example. This example has lots of decimal points and you can check it out there. The first thing we're going to have to form is the three matrices we have done in the previous case. So we have 0.8, -0.5, -2.4, and 1.7. Then we have XY, we have 0.85 and 3.05. The three matrices, the matrix of coefficients, the matrix of the unknowns, and the matrix of the answers. Again, we look for the inverse. First of all, obtaining the determinant, which is 0.8 times 1.7 minus -2.4 times -0.5, and that gives us 0.16. The inverse will be the reciprocal of that times the transposed matrix, where we have 1.7 and 0.8 reversed like this. And the signs for 0.5 and 2.4 also reversed. That you have 0.5 and 2.4 respectively, this time around being positive. Please simplify this part here and you're going to get this particular matrix, which also has many decimals, but it should be able to operate that since we just follow the rules of multiplication, even of integers. Again, we pre-multiply this inverse that we just obtained with the matrix that we had at this particular stage, with the matrices that we had at this particular stage, so that this particular matrix goes before the matrix of coefficients, like this, and the same matrix goes before the matrix of answers, like this particular case here. Again, before the equal sign, everything reduces to XY, like this. But what work we have for us is simply to simplify anything that we have after the equal sign. So the matrix, the inverse we just obtained, times the matrix of the answers, and following the rules of multiplication of matrices should give us the matrix 18.5625 and 28. That tells you that the answer for x is 18.5625 and y is simply 28. You can always verify this by using another method of solution for simultaneous equations. Please check out one more video to wind up the lessons on the topic of matrices, which is a peculiar example. Thank you.